Welcome back, and here's our next video on do we have a max or a min, and this is a different strategy called the second derivative test. What it basically uses is the idea of if you have a critical number, could you figure out if you have a max or a min depending on the type of concavity. So here's how it works. You basically are going to have your critical numbers. Remember, those are the candidates for if you have a max or a min, and this comes from when the first derivative equals 0 or is undefined. Just write it right underneath. Now, usually what happens is to decide if a critical number is a max or a min, we use the first derivative in a number line. But what we're going to do this time is we're going to find the second derivative, not set it equal to 0 or anything like that. What we're going to do is we're going to plug in the critical numbers into the second derivative. And what that'll tell us is that if I get a positive number, that means that, if you're positive, you're happy, you're concave up. And if you think about it, what kind of extrema would you have if you're concave up? You'd have to be a min. If I get a negative, I'm sad, and it means I'm concave down. But if I'm concave down, the type of extrema you'd have would be a max. Okay, so let's test this idea out. So I'm going to make up a cubic because I can. And although it looks weird when books write 1/3, they just do it because it makes the problems nicer, actually. Okay, so if I asked find all the extrema of this function, right? I want to know if I have a max or a min and where they're at. Then what I would do is find the first derivative. That 3 is going to come down. 3 times a third is 1x squared. And then I'm going to have minus 4x. Okay. Now again, I'm trying to find maxes or mins, so I'm going to set this equal to 0. And I can factor out an x. And I get two critical numbers. And those critical numbers are 0 and 4. Okay, now normally at this point we do a number line and test into the first derivative. But what I'm going to do now is this new thing called the second derivative test. I'm going to find the second derivative and then plug in to see if it's up or down. So let's try this. Okay, so let's look at our function. So my second derivative, let's write it right here. Let's see, would be 2x minus 4. Okay, so what I'm going to do is I'm going to plug in my critical number of 0 and also my critical number of 4 because I want to know, are these a max or a min? So when I plug in 0, I get 2 times 0 minus 4. I get a negative 4. If I'm negative, I'm sad. And if I'm sad, I'm concave down. And if I'm concave down, that means that I'm a max. Right? See the picture? Down, so it'd have to be a max. So I know I have a max at 0. Okay, now we're going to try it again for 4. So let's see, 2 times 4 minus 4. That's 8 minus 4, which is 4. I'm positive, I'm happy. But if I look at that shape, the kind of extreme I'd have would be a min. Okay, so I have a max at 0, a relative max. And I have a min at 4. Now, I do need the y-coordinates. So to get the y-coordinates, you always go back to the original function. So up here at the original, I need to plug in 0. When I plug in 0, I get 0 minus 0 is 0. So that one's nice. And right about now is when I'm now regretting that I chose a 1/3. Okay, so let's see. 4 cubed is 64. So 64 thirds minus 2 times 16 would be 32. Oh, man. 64 thirds minus 32. Okay, if I make a common denominator, I think that's going to be 96. So 64 thirds minus 96 thirds. I think I'm going to get the lovely negative 32 thirds. Man, is that gorgeous. Okay. And there we have it. That is the second derivative test for determining if you have a max or a min.